Hey guys, hopefully if you're watching this, it's because you've already finished your kinetic theory project and have turned it in to myself or Mrs. Coolidge for us to view so we can get you a grade. Remember, if you were passing on March 13th and you don't engage, you don't do any of these projects that we're asking you to do, you're going to take whatever your grade is right now, which is pretty good, and reduce it to just credit. It doesn't affect your grade point average, but for a lot of you, this class you were getting A's in, you want that on your grade point average. So make sure you're engaging. These are supposed to be fun, easy lessons and something that anybody can do. And if you're not sure what I'm saying, we're going to have that time on Thursday to engage with you guys through Zoom. So you'll just load up Zoom and you can talk. You can also email me anytime you want, and I will answer your emails, and we'll make sure we're talking that way as well. So the next topic is static electricity, and we're talking about what is static electricity. Well, you just got through with kinetic theory, and that was all objects have minute particles, they're in constant motion, and they have cohesive and adhesive bonds. All of that is like the molecular level, the atom level, where you know, if you took an atom and enlarged it to a football field, the nucleus would be like an ant, and these little electrons that we're going to be talking about right now, you still wouldn't see them. They're so small. So they're really, really tiny. So kinetic theory was really, it's talking about all the particles, but more the molecule atom side of things. Okay, the next thing we want to do then is move to smaller. If you haven't noticed, we started with gravity at the beginning of the class. We've reduced it now to a very tiny object called an electron. And protons have nothing to do with static charge. Protons determine what the element is. Look at the atomic number. That's how many protons it has. If the proton number changes, the product isn't what it used to be, or the element isn't what it used to be. If I had helium and I added a proton, it would be, or I'm sorry, if I had hydrogen and I added a proton, I'd get helium. So when you're playing with molecules, that nucleus doesn't change. If you're playing with a neutron, you're playing with nuclear energy. You're playing with an isotope. You're playing with how radioactive is it. You're playing with protons, you're literally determining the element of the number. So what we're going to be playing with is electrons. And a positive charge isn't too many protons. You have exactly the number of protons you have to have in order to be whatever the object is. What can have too many is an electron. In chemistry, you probably learned that these were cations, is what they're called, when they have too many or too few electrons, and it's a positive charge or a positive ion. If it's a negative ion, then you have too many electrons, and we call that an anion. So ionic charges or ions are atoms that have too many or too few electrons. We're just going to be, we're not even playing with a charged atom. We're going to go right down to the electrons, and we're going to be playing with those. And so we're going to end up doing the same kind of thing. We're going to end up in a project where you're going to demonstrate your knowledge of electrons. That's it for this one.